Good afternoon, everyone, and welcome to our webinar focusing on exoskeleton research. For those who don't know me, my name is Johnston, Impact Manager at BE-ST, formerly known as CSIC Construction Scotland Innovation Centre. Delighted to be joined today by our co-partners in the project. We've got Graeme Bisland from NMIS, National Manufacturing Institute Scotland, and Xiu-Tian from Strathclyde University. Cameron Swanson, also from NMIS, will also be joining us for the Q&A later on. You'll hear more about the project from Graeme, but however, just quickly to mention, the project is funded by Interreg, a European funded project, with the main objective to increase the adoption of exoskeleton suits in industry. For BE-ST in particular, this is more the built environment and construction, but for the wider partnership, and there is a wider partnership of 12 other partners across the North Sea region of Europe, they're concentrating on other industries, including biomedical and manufacturing and automotive. I would just like to stress that the project is not to recommend any particular suits and to have a preference one over the other. It's more for us to provide an honest assessment of their use cases and, if appropriate, provide recommendations to developers and manufacturers with the whole intention to improve the next generation of exoskeleton suits. And we can do that through the combined consortium that's been pulled together as part of this Interreg project. Just before we get underway with the formal presentations, just to highlight some housekeeping points to help the webinar run as smoothly as possible. Firstly, to mention, the session has been recorded and it will be available in the coming days. We'll get that posted out to you. All participants will be on mute for the duration of the webinar, but you can please post any questions on the control panel that you'll see on the right-hand side of your screen. There is a Q&A session at the end, so we will pick up on your questions. Your feedback and opinions are really important to us, so we'll keep an eye on that. If for any reason we don't get to all your questions during the formal Q&A, we'll follow up separately with you. Just to also mention, there are interactive polls at the end of each key segment today. So please answer them as best that you can. We'll display the results for a few seconds during the webinar, but if for any reason that there's something you want to follow up on, again, just please put it in the chat that you've got on the screen there. Just while I'm finishing off, before we hand over to Graeme, you'll see a short video showcasing some of the work of the exoskeleton project to date. The project is known as EXSKALLERATE. So in a second, you'll see this video and then we'll hear from Graeme Bisland. Thank you for now. This project's about the adoption of exoskeleton suits in construction and manufacturing.
The exoskeletons are designed to provide support for the upper and lower back for the users so that over prolonged use they feel benefits and they won't develop long-term back injuries.
So this is one of our field labs. This is a third field lab. And the guys behind us here are building timber frame panels. So they're using exoskeleton suits to try them out to see if there's any benefits and advantages. So the project is all about how we test and measure the benefits of the suits undertaking a variety of construction tasks. Our first one was the roofing field lab. So that was successfully completed in October.
and our second one was plasterboard in field labs, so it was fitting wall and ceiling plasterboarding.
We're doing testing with the Oxivio and HeroWare exoskeletons. They're passive suits. So during this testing, we'll be providing GOM scanners, so GOM Aramis SRX scanners that we're using to do motion tracking. So we'll be placing markers on the guys' suits and on their bodies so that we can track their motion while they're actually performing real-life tasks. Start with an interview with the operators so that we can understand the activity that they're going to take part in. From that, we will then understand which parts of that activity and which parts of the real-life activity that they're doing will actually gain benefit from the use of the exoskeleton, mainly activities where they'll be using their back or in an uncomfortable or a twist sort of operation. From that, we then focus on measuring those activities as part of the real-life trial, and then at the back end we'll do a follow-up interview to see how they actually felt the experience of wearing the suit was. Did they feel benefit? Did they feel any extra restriction from wearing that suit?
When you're working, you can feel your back is like it's like correcting your posture, and I think that's when you're bending down, you're just not used to like being that natural kind of shape, eh? You're used to twisting and that.
What we're trying to understand is what the limitations and what the benefits of these suits are, and then potentially identify design improvements that could be implemented or recommendations that could be implemented for actual use that we can then pass on to the industry.
The project's funded through Interreg. It's a European funded project. It's actually a consortium of 12 different organisations across the North Sea region of Europe. We're the only consortium partner in the UK alongside University of Strathclyde and NMIS, the National Manufacturing Institute Scotland. The future, hopefully, of exoskeletons is that we see an adoption of the suits across the construction industry, and organisations get the benefit and their workers get the benefits of using the suits.
We'll now hear from Graeme Bisland of NMIS, who will provide a presentation.
Good afternoon, everyone. Thank you, Alan, for the introduction. I'll go to my presentation. So, as Alan said, the EXSKALLERATE aim is to accelerate the adoption of exoskeletons into construction, industrial manufacturing and SMEs, where heavy physical work leads to severe health injuries and issues. It's a partnership of 6 North Sea region countries. Within each of these countries, there's a number of research institutes and organisations. We have countries represented as Netherlands, Belgium, Germany, the UK, Denmark and Sweden. Within the UK, as Alan said, it's BE-ST, National Manufacturing Institute Scotland and University of Strathclyde are all present here today. The EXSKALLERATE project looks to contribute to SMEs' competitiveness in occupational health by making the North Sea region a leading exoskeleton ecosystem. The consortium of businesses and support organisations and research institutes will do this through 3 main activities, which we've discussed in brief there. So we have the field labs and pilot sites where we'll be testing and doing analysis of exosuits, exoskeletons, and getting user feedback and insight on their use. We'll also have informative webinars and workshops such as this one today, where we'll be disseminating results and discussing design improvements that could be implemented to cater to specific industries. There's also work on transnational benchmarking. So what we're looking to do here is create knowledge hubs and look for standardization and sharing of knowledge in terms of best practices for the use of exoskeletons in industry. So why exoskeletons? As many as 44 million workers in the EU are affected by a workplace-related musculoskeletal musculoskeletal disorders, MSDs, at a total annual cost in excess of 240 billion to the European economy. So exoskeletons have been identified as a potential means and have the capacity to decrease the number of musculoskeletal, I'll get that word right, injuries, and increase the quality of life at work for their users. And at that, I'll hand across to Alan just to do some questions and get some feedback on from yourselves.
So we should just have a poll coming up soon. So on the poll here, if you could just respond as best you can, and please tick all that apply. They're really looking to determine the likelihood and commonplace for these type of events. So you've got just about a minute to tick the ones that apply, if you don't mind, and we'll see the results on your screen in a second. Yeah, well, we've got 100% there and on-site injuries and lower and upper back injuries. So it demonstrates the importance of what an exoskeleton suit can do in terms of protecting the workforce. And we should have another poll come up. Yeah, so this is partly to determine what is seen as the most important to you in terms of you and your business. Again, select as many as appropriate. A dead heat there, but again, no surprises there in terms of reduced opportunity getting injured and increased comfort and posture support. Again, another two big advantages of using the exosuits, or what we've experienced with using the suits today. And we've got a third question and third poll in this segment. Yeah, this particular question will help us feedback to the developers, manufacturers of the suit. I should point out as well, you will notice that we've got a selection on some of the poll questions on other. If you feel there is another, please feel free just to post in the chat box. Yeah, again, very useful intel for us. And like I say, that's something that we'd be looking to feedback into the wider consortium, and particular feedback to the developers. Just hand back to Graeme.
Fantastic. Let me just check. Okay, see my screen again. So as we said, we hosted a number of field labs. This was in collaboration with BE-ST, NMIS, and University of Strathclyde. The focus of these labs is to explore the user experience while wearing the exoskeletons and conducting typical construction activities. The key part of this is constructing the doing typical construction activities. So we're not wanting to do everything that's abstract. We're wanting to actually have people doing physical parts of their job, and that's where BE-ST were able to provide representative environments for each one of these field labs. Also part of that is making sure that we're using real operators, and as such we engaged with Donaldson Group, which was formerly Stewart Milne Timber Systems, AC White, Forster Roofing, and Morris and Spottiswoode. So exoskeletons themselves. Exoskeletons come in two flavors. We have active exoskeletons and passive exoskeletons. An active exoskeleton uses actuators and motors to provide strength or increase strength of its users and provide support for them. A passive exoskeleton looks to store energy through the use of springs or tension bands to allow the users to then use that energy in a more useful way. So what we focused on, for simplicity's sake, was passive exosuits. We looked at 2 different exosuits on the market, a HeroWear one and an Oxivo suit. The HeroWear suit, as I said, is a passive suit. It focuses on reducing strain on the back, and it comes with a number of interchangeable parts and adjustments, specifically catering to a broad range of users. It also has a feature which allows the user to disengage the suit with a small clutch which is located on their chest. This means that when the user is doing activities where they may not want to have the exosuit engaged or doing anything, they can quickly hit this and release it so they can get on with that activity and then reactivate the suit when they need it. The Oxivo suit provides support with back and hip muscles. Again, it's a passive suit, and it also allows an element of adjustment through adjustment of straps and what have you, but didn't come with interchangeable components. The exoskeleton anatomy. So most exoskeleton suits and these passive ones we looked at are very similar. They consist of 3 main components. The back strap, which is similar to a backpack or a vest, where it goes on the user's back and is mainly what holds it in position for them. The thigh straps, which go around their thighs, and then these are connected onto the tension bands between the 2 components. You can see the tension bands marked there, and this is the piece that's doing most of the work and storing the energy for use by the user. As we said, we'd done 3 field labs. We looked at roofing, plasterboard, and off-site. So the roofing, we looked at the carrying, fixing of tiles onto a roof. The plasterboard was the carrying and positioning, fixing of plasterboards on walls and ceilings. And the off-site was the construction of off-site cassettes. Within each of these field labs, as we said in the video, we hosted interviews with the attendees to understand what key activities within each of these we believed that the exosuits, exoskeletons would provide assistance with. For the roofing, this included the lifting tiles onto shoulder. So this is a user picking up a stack of 6 roof tiles, which is about 30 kilograms, off of a floor or a ground position, and placing them onto their shoulder. Next task was lowering the tiles onto the roof. So while the user's on the roof, then positioning this stack of 6 tiles at their feet for use. And then finally, the laying of the tiles. So while in a sort of bending squatting position, stretching and reaching across the roof and placing the tiles in their final position. So a lot of these activities involve squatting, lifting, bending, and stretching. For the plasterboard field lab, we looked at moving plasterboard with 2 people, a plasterboard sheet being about 23 kilo, from a stack on the ground onto a lifter. We also looked at turning of a board, so 2 people lifting and repositioning a plasterboard from a horizontal orientation to a vertical orientation, and also the nailing of plasterboard. So nailing a plasterboard sheet onto a wall at both top position, so stretching up and nailing up high, in the bottom position, so squatting down and nailing low, and also overhead onto a ceiling, so prolonged use on a ceiling. And for the ceiling activity, we again used a lifter. And the off-site field lab, the activities we identified here was one we called dynamic nail gun. We kind of struggled a bit for a name for that one, but this is where the user, while bent or stooped over, would move along the length of the cassette, fixing panels in place with a nail gun. Then the static nail gun, so this is the user standing still, positioning a small beam in the cassette, and then while they're holding that with one hand, using their other hand to nail that in position. And then finally, we looked at circular sawing here, where the user would crawl along the length of the cassette, cutting off any excess panel that was not needed. Within the field labs, we used a motion tracker, the GOM Aramis SRX. So this allows us to monitor markers. It's a dynamic measurement system. It's quite powerful, and we measure things very accurately. We used a basic heart rate monitor, a Garmin wristwatch, and as we said, we'd also use feedback questionnaires. So the results from the field lab, the heart rate data showed no meaningful results, unfortunately. We found that due to the variability of the tasks that were being done and the stop-start nature of the field lab itself, we're unable to note any noticeable improvement or difference at all between users operating with and without the exosuits on. The motion scanners, however, did give us some very good results. It allowed us to record and measure users' motion, so measure distance and time, as well as having video output. You can see on the left here, output file from the GOM software that we were using. This allowed us, as you can see, to look at tracking of a marker in space and analyze that motion and understand exactly what the user's been doing without suit, with suit, the two suits which we had. And finally, the feedback questionnaires excuse me, allowed us to gain objective and subjective feedback from the users on their experience of wearing the suit. So information such as how their comfort was, their sense of the quality of the suits that they were wearing, and any features and things that they were interested in seeing or felt that the suit could have done better. From these field labs, there was a lot of observations and results that we got, but mainly we've grouped these into sort of two categories, behavioural changes and flexibility changes. We noticed a number of different behavioural changes in the way the users were operating with and without suit. What you see here is a user from the plasterboard trial. The top row here is without suit, and the bottom row is with the HeroWear suit. And you can see a number of stages here, 1 to 5, and this is a user orientating a suit, sheet of plasterboard from a horizontal position to a vertical position. Most of the activity is unaffected by the use of the suit, apart from action 4, which you can see here highlighted in yellow. Here, the user with the suit on is actually now taking a more squatted position, so they're actually bending their knees more and getting lower relative to the sheet to allow them to reposition it. This can have benefits to them in terms of the way that they're squatting, so they're not leaning as far, they're not exerting themselves as much. So this could potentially be a benefit to mitigating musculoskeletal injuries. Similarly, another behavioural change here, where again the plasterboard trial between the HeroWear suit and no suit. No suit again being on the top, HeroWear being on the bottom. Here we have 1 to 6, and the user is the 2-man lift from the stack of plasterboard onto the lifter. We see here that there's 2 points where we could note change in behaviour in positions 2 and position 4. In position 2, again, similar to the last trial, we see that the user is using their knees, they're bending down and picking up the plasterboard sheet. Again, this can have benefits to the amount of stretch and strain that they may be putting on their back. And then on number 4, we see that the users actually reposition themselves more to the side rather than stretching and exerting themselves from a square on position to the camera. In addition, they're also bending their knees a bit more in position 4 as well. And again, this, as we've said, can have benefits for the potential risk that they may be having of long-term injury. Then looking at flexibility changes, here we have someone doing a forward reach. On the left graphs, you can see the results from the roofing trial, one of the users, and on the right, you can see one of the users from the off-site work. We have 3 sets of data here for the HeroWear, no suit, and the Oxivo for each. What's noticeable here is from the roofing trial, we can see that the user's flexibility is actually reduced with the use of the suit. This may not be necessarily a bad thing. Again, as we've said, the user may not be exerting themselves as much, in which case they may be offsetting potential injury, which is actually a good thing. Whereas on the cassette building on the right, you can see that the use of the suit hasn't actually had a significant impact in terms of the amount of reach that the user is able to have. So the height obviously is reflective to how far the user is reaching. What this means is that different users are experiencing the suit in different ways and reacting differently to it. This could be partly due to the short-term duration of the field lab work we've been doing. It could be just down to user preference or just behaviours building up over time. And at that, I'll hand back to Alan to put up some more questions.
Helen, you're still on mute. That's it.
Yeah, we should just have another 3 poll questions coming up. So what environment would you consider using the exoskeletons in? Again, select all that apply. Again, it just helps with our intelligence gathering. Yeah, we must have a lot of construction built environment people, but yeah, I would see the relative to the other uses as well, which is really important in terms of the type of suit and how they can be used. Thank you. We should have question 5. Yeah, fairly self-explanatory, this one. So where do you see the benefits? What type of activity movement would you want a suit to provide support for? Yeah, in terms of carrying lifting from the ground, that is definitely one of the main benefits, and also the general manual handling is definitely where an exosuit you would get most advantages from. Just the final. With this question, there is a case of the regularity of use and how it's likely to be used. So for some type of activity, you would want it to be on all day, but for others, you know, there might be a view that you know, removed for certain activities where maybe people would deem it to be obstructive, or in the final one there, you wouldn't really wear it until you really had to. So again, just in terms of your industry, your thoughts on that? Okay, that's very interesting. So it would be a case of using it as and when required. That is interesting, because there is some school of thought about the second and third would be the most effective way. So yeah, thank you for that. And I think that's Graeme finished with his final slide. Yeah, as such, I'd just like to thank Graeme for that very informative and comprehensive overview. And just a little note again to the audience that, you know, if you have any questions, please feel free to type into the tab there, and we'll definitely pick up at the end. So we've now got Xiu. I'll provide a presentation. Thank you.
Xiu, you're still on mute. You can just hover over to unmute your mic. Thanks.
Good afternoon, everybody. Can you hear me and see my slides okay?
Yes, thank you.
Okay, good afternoon, everybody. For those who don't know me, my name is Professor Xiu-Tian. I coordinate robotics and autonomous systems group at the University of Strathclyde, based in the Department of Design, Manufacturing, Engineering and Management. Today's topic is I'm going to focus on the research side of the exoskeleton robotics, in particular focus on construction industry. So from Graeme's talk, I think you got a very good idea about the sort of exoskeleton robotics we have been looking at. Just for a slight broader context for those who are interested in general manufacturing, are also be involved in the Made Smart Research Center for smart collaborative industrial robotics. lead one of this research priority area, which is looking at broader robotics, including exoskeleton robotics. So if you're interested in those areas, you can probably contact me. So as I said, my topic is going to be focused on the research side, based on what Graeme has presented. That covers a wide range of project activities. So I'm going to focus on some of the research interests that we have. And we'll start with the research questions. So what we essentially try to do in this particular research work. There are a number of exoskeleton robotics available on market, but it's always difficult to know exactly how effective they are in terms of supporting an operator. So an obvious question we can start with is to find a way to measure the effectiveness of one of these either passive exoskeleton robots or active ones. The one we use in this project is a passive one, so we need to focus on the passive robotics and try to measure and benchmark perhaps to some extent to see how they perform in supporting the operator. So we have done a number of field activities. This is the laying tile operation. As you can see on this image, I'll hopefully give you some idea. There are a number of markers we use to basically try to allow us to track that particular marker's movement or the body associated or marked by that particular marker, and to give us a bit insights about how people using exoskeleton or without using exoskeleton. So you can see on the left-hand side, these are the markers appearing on many places on the head, the shoulder, the back, and the back is a very important part, and also the leg and foot, etc. So with these markers, and we track this motion, and then we'll be able to measure how that person performs without wearing exoskeleton robots. On this one, you can see markers still in the same place, and then the person wears one of the exoskeleton robots. And we, in this case, we use two approaches. So the actual approach we take is to because this is the first time we do it, and we haven't seen much report in the literature, so we're not quite sure now what would be the best way. So we decided to use the two approaches in order for us to have a bit more scientific way of measuring these devices. So the first approach uses GOM, Aramex camera-based system, and then the second approach that we take is using optic track that allows us to measure system. With so many points before the test, it's difficult to know where would be the key things we should measure and where would be sensible distances we measure. So after after some considerations, and then with the available data captures, so we decided we probably focus on two parts of the body movement. The first part is from head to hip, and try to measure the distance so we know how much the upper body of the operator actually bends or moves around. The other part we want to measure, so be sensible to measure, is from the hip to foot. So from here to the foot, there's a distance here, and try to see, essentially measure how much leg bendings work this operator is performing. So that's a kind of a way we thought would be probably a representative of what that person is actually doing during the tile laying process. On the right hand side here, you can see two charts we got from those two measurements, head to hip displacement. The blue line represents the mean values wearing exoskeleton robots. The yellow line is the mean value without exoskeleton. So perhaps the positive results from this is they are very consistent across a whole range of a number of measurements. So the mean value for the person with the exoskeleton is consistently higher or bigger than the case where he doesn't wear the suit. What that does basically tell us is the distance from the head to the hip is bigger when you wear the exoskeleton robot, so implying probably there will be less bendings because you have bigger distance across all these 18 trial points that we measured. Similarly, if we look at this slides from the hip to the foot distance, when the person wear the exoskeleton, the distance is significantly bigger than the distance when that person does not wear the suit. So again, indicating this person is bending less and that probably, hopefully, likely will reduce the likely injuries to that person. So that's the first test we have done. The second, or the results I'll probably show you, and the second results I'd like to share with you is a probably play video. It doesn't play well. So this is a plaster nailing operation. You can see on the left-hand image here. So the operator have to constantly lift and lower the screw guns, and in order to make that operation. And during this process, then we also use this optic track to track the body movement. So in this case, you'll see several markers in triangular form. So essentially, we can measure the three-dimensional information of this person, give us a bit extra information as to how this person moves around and while he's lifting or lowering the screw guns, and then what moment that person is involved in that process. So we have done other things I probably also would like to share with this particular flooring task. And for the flooring task, this gentleman has obviously tried to use the our screwdrivers to attach the board. Again, we measure the using the optical track system to measure the distance, and the preliminary results suggest that this blue line indicate distance when the person is wear the suit, and the distance you can see is about 0.35 meter in comparison to the other case where there's no suit is wear, it's about 0.3 meter. So again, this distance is bigger between the mid back and the shoulder points, so it's roughly indicating bigger distance indicated less upper body bending movement with the exoskeleton robots during our operation. Similarly, mid back to shoulder distance with the suit. This is another one. The first one is the waist to the shoulder, and this is mid back to the shoulders. Give us a bit more measurement here. Again, it tells us overall when the person wear the suit tend to bend less in comparison with larger suits. Hopefully that gives this is quite a reasonable, consistent set of results here. The other approach we have also done is try to measure the, I was trying to get feedback by designing a set of questionnaire. So we're basically asking those questions about how comfortable the hero wear is, and how safe they feel they are, and how stiff they are, and the range of motions this hero wear allows the operator to move around, and physical exertions. So ask these questions, aesthetics, etc., and ask them to rate from 1 to 7, 7 being probably best towards the end. So you can see overall the answer is clustered around this area here between 4 and 5, 6. So overall, from the feedback from 4 workers indicated a positive experience during the trials we have done for those sets of tests. These results just remind previous results. I only showed you 2 specific operations. This result it covers all the field lab activities we have done: 3 roof operation tasks and 3 plaster and board operations. So it's to give you a more kind of a summary results of the indication of that. So in conclusion, from the field trial we have done so far, we can probably draw these few conclusions. So overall, operator experience shorter distance between sample points of the joint, and this suggests a shorter or better body movement during the tasks we showed in my presentation, and this suggests they have a straighter back, and we can't measure directly on the stress on the back muscles, but this could also suggest probably better angles and less in that regard. And then we need to do more work, try to find out does the operator actually experience less stress on the back. That's something we can't tell you at this stage. So this, if this is true, then we can probably, or the suggested benefits, it could be reduced fatigue during the construction typical operations we have trialed on, and this could lead to the reduced chance of injuries between due to kind of sustained stress on the back or the upper leg part of the body. Another potential benefit could be reduced downtime and increased productivity, production efficiency and productivity, etc. This study is very preliminary, and there's those results are presented seem to suggest that there are positive feedback, but there are other data we captured does not really tell us, like this one here is as example. In some cases, the distance between the waist and shoulder varies between two cases, so there's not very conclusive results we can tell you at this point of time. So it requires further research further to find out what we're going to do, or if the system actually provides a real benefit. So there's still uncertainty in some of these conclusions I suggest there. So this is the first set of field trials we have done. So we obviously want to continue to build on what we have done. One of the areas is try to look at the long-term benefits of wearing these suits. And the suits we have demonstrated relatively short one-day trials for each of these tasks. But we don't know how this suit will impact on the operators when they wear this for a sustained period of time, and if the person actually gets used to this system or not. The system, the exoskeleton spatial passive one, is still early stage of their product, kind of introduction to the market, and also the use adoption by the overall operators. So still a lot of improvements need to be made, and we see from the questionnaire there are certain areas you already identify. So we want to build on the work we have done and the feedback we received from you in order to find out more kind of specific functionalities we should introduce specifically for construction industry. So this is a quite unique sector where different type of operations, different type of stress and that kind of burdens put onto the operators. So we would very much like to see these technologies being widely used, at the same time try to improve it with more added desirable functionalities to the system. So at that point, I would like to hand over to Alan for about the future engagement if you wish to make. Thank you for your attention.
Thank you very much, Xiu. Another very informative session. I hope the audience has got a better understanding of our projects and our aims going forward with the project. Just before we cover off this slide, I think we should have another couple of poll questions coming up. Okay, how would you share and allocate exoskeletons among trained staff? This will help us determine a bit of regularity of use, if you like. I mean, there is a time period to don the suits on and off, so that has to be considered, and that's what this question is alluding to. Okay, yeah, good feedback. Because again, it's something that we have considered. Is it something that's more of a shared tool, given the cost, and I'll pick up on cost actually, or is it seen as a dedicated suit per person? Thank you. Another poll, please. Again, this is good for us to feedback to the developers and the manufacturers in terms of what else could be incorporated for the next generation of suits. %200 there. They're all quite high. So looking at all four of them, it's something that we definitely consider and provide feedback to the developers and the wider consortium that Graeme mentioned earlier on. There's 12 other partners. Thank you. And one final poll, I believe. Okay, yeah, I alluded to cost in one of the earlier polls. So again, you know, just to get some thoughts on cost of a suit. Well, what I should say, I mean, the prices vary widely, to be quite honest with you. They are passive suits, so nowhere near expensive as some of the robotics, but you're probably talking, you know, £200–300, £700. Some suits are up to £1,000. Yeah, that's not a surprise really. All has to be considered in terms of the whole idea of the project is adopting the suits for the construction industry, and cost and return on investment is very much an important part of that. Thank you. I think that's our final poll. In terms of future engagement, so a few key areas that we're still to deliver as part of the project, very much welcome your involvement, or, you know, spreading the word of your involvement in the project. I've just seem to have lost the detail of the slide there, but never mind. So we've still got the pilot sites to be delivered. So the pilot sites, so now we've done the field tests, the field labs. The pilot sites are an opportunity really to take the suits out to the workplace. The important part of that is that we're able to test things over time, which will include a questionnaire, because we do recognise that the field labs are time limited. So this is more a case of allowing users to try them more during their everyday activity, and hopefully we could do that for maybe as long as 5 days or so, and I think it gets us a better user feedback and overall analysis of the adaptability and usability of the suits. SMEs are mentioned, but that's actually part of the funding criteria that we target SMEs for the pilot sites element of the project. However, what I would also like to mention is that you might not be an SME but still interested in getting further involved. We can still actually do that. So we've got the ability and capability to undertake some of this work at our own innovation factory at BE-ST, which is based in Lanarkshire in the west of Scotland. So please get in touch if you'd be interested in the pilot site, that either being on one of your own live projects, or, like I say, we could accommodate you at our innovation factory in Lanarkshire. The other, I don't know if that slide has actually come back up yet, but the other element that is important to us is to deliver a design improvement workshop. That's more targeted at people who have got direct experience of using the suits. That way that we can actually have a real in-depth discussion and look at generating the potential for design improvements for the two suits that we're looking at, the Xevo and the HeroWare suit. So we are working with a few parties at the moment, a few organisations, very much looking at designing this workshop, and including, for example, health and safety type managers, training managers, and general operatives who've got the experience of using the suits, and then that will help us with that design improvement workshop. Finally, one of the other key things is more dissemination events such as this. So keep an eye on social media, LinkedIn, the website, you'll have a link to that. There's a QR code here as well. On the QR code, you can actually access that just now, where it takes you to the pilot sites that I was talking about and a contact forum. So please feel free to use that, or we will be following up with an email as well. So that's our future engagement activity. Okay, that slide's finished now, Xiu. And we just moved to our Q&A session. If you could just take that slide off and everyone can share their cameras. Thank you. So you've heard from Graeme and Xiu. Thanks again, Graeme, Xiu, and Cameron's joined us as well, a colleague of Graeme's at NMIS. So we'll just go ahead as part of the Q&A sessions. I'll just have a look through some of the questions we've got here, and I'll field them as best as I can. First question I've got here is, how long does each worker train with the suit before testing, and how long do workers wear the suits during the actual tests? In terms of, Graeme, in terms of the field lab testing, are you quite happy to answer that?
Yeah, definitely, Alan. So the field labs themselves took place between 2 to 3 days. The workers, typically the first day would be testing the workers with a range of motion, so we'd fit them with the suit, go through risk assessment, health and safety stuff for attending the site and the usual sort of admin activities, and get them properly fitted with the suit itself. We'd also then on that day look to do some of the sort of range of motion work. So there was 6 or 7 sort of stretches, squats and activities like that we would have the worker do to kind of familiarise himself a bit with the suit, as well as allow us to sort of set a datum for the sort of future activities we'll be doing the following days. The actual field labs themselves would be then the next day or 2 days that would take place, and as we said, this was where we feel like we maybe had too small of a sort of exposure time for them. So there was a lot of start-stops as we were setting up equipment to repeat activities, because we want to see that repetition of what they're doing so that we can compare results. So probably active time in the suits, the users were probably throughout the field lab maybe 4 hours or so in terms of actively doing the activities. But yeah, it would be over a 2-day period that they'd be actually using it as part of their work. And that's where we're hoping that the pilot sites will kind of subsidise some of that time that we've had. And I think that will certainly help a lot with the acclimatisation and sort of people getting used to it and getting their own sort of what's their natural way to respond to the suits operation.
Yeah, thanks, Graeme, and a very good question. The next question I've got are, what are the next stages of the project? I think we've probably covered that, but I'll also talk about the legacy of the project. So I think we've covered the next stages of projects, mentioned the pilot sites, which building on Graeme's point there, it'll be more of a longer term in-depth user experience of the suits, so that'll be invaluable. I mentioned design improvement workshops, again that will help for the next generation of suits and feeding back to the developers, and future events and dissemination. And I briefly mentioned as well about the innovation factor at BE-ST. I've got the suits are always on display, and we're also always looking at demo days that people can come out and experience the suits. Just very quickly, in terms of a bit of a legacy, we're already talking to the partners about what happens next, and you know, we could have a follow-on for this initial project period. What I should mention, I probably should have mentioned it at the outset, the project conclusion is June next year, so we'll still get a full year in terms of delivering the rest of the objectives, the pilot sites, the design improvement workshops, and any demo days. So we'll still get a good window of opportunity that I should have probably mentioned at the outset. We've got a question that's come in out with the actual chat. So asking about health and safety executive. So yeah, the health and safety, what's the involvement from the health and safety executive? So the health and safety executive are very interested in the work we're doing with the suits. The construction technology unit at the HSCs are actually a fairly newly formed unit, and they're taking a particular interest in exoskeletons and the project that we're involved in. Just scroll on to see if there's any more here. Question, I think we'll more or less answered one of the other questions that have come up there. Oh, question here about the weather, and does are the suits affected by weather? Again, partly going back to, you know, working on a live project, live sites, again, that kind of helps determine that type of thing. What I would say is that the manufacturers, developers, they do give good guidance on, you know, the weatherproofing of the suits and actually the cleaning of the suits as well. So both suits are weatherproof to a point, if you like. I don't know in terms of how far that goes in terms of long-term winters in Scotland that can be very severe, as we all know, but certainly the suits that we've tested, they do have weatherproofing on both suits. Snow is the other question as well, which, yeah, like anything, I think like any type of PPE as well, that, you know, through time, I'm pretty sure that it probably can get a bit heavy if it's saturated. A question here specifically about the hero wear, and along the lines of, did we have the different type of options for hero wear? So that's someone obviously knows about the hero wear suit. Yes, we did. We had what's known as a fit kit. What the fit kit actually does, so you can buy the hero wear suit, but you also can purchase the fit kit, which basically allows for different sizes of people, you know, in terms of male, female, different upper body, lower body. It allows different elastics and different bands that could be used as part of that. And the other part of that question is what did they like best? That's probably something I think we could probably certainly take offline. I think that's someone that really knows about their hero wear suit. I mean, I think a quick answer to that is that during the test, that the participants seen many advantages. You know, that some constraints were mentioned as well. Okay, I think that's us picked up the questions. So just really to wrap up the session, again, we'd really like to thank our presenters. Sorry, Cameron, you didn't get a chance to speak there, but very much thank you to the audience as well for taking the time to join us today. Very valuable, and thank you for the questions. Your feedback is really important to us, so you will be given a link to complete some feedback after the event, so really encourage you to do that, because it really helps us for future events. So it looks as if we're very much on time. I hope it's been an informative session, and like I say, keep an eye out for future activity, future events, and we'll be having more webinars like this. So have a good afternoon, what's left of it, and take care. Thank you. Bye-bye.
Thank you. Bye-bye.